Alright, so today I took or yesterday, because it's like 12:30 in the morning right now, I took the AP Computer Science exam for 2017, and I think I passed. I probably got a 3, but I was probably just shy of getting a 4, and that's because I didn't spend enough time practicing Part 2 questions. Now, I'm not really a good test taker, and I suggest if you're the same way, then Part 2s you definitely need to practice. Like, everyone practice multiple choice. You can't forget about Part 2 questions. Um, What happened with me is I had the implementation in my head, but I panicked. I kept thinking about time pressure, and that eventually made me lose some points. Um, so what I would suggest is just some tips. If you're taking the test and you're on part two, you have to relax during part two. You need to take a lot of time planning these out, and you don't really need a lot of time to write them out because you already have the whole plan written down, and then you just need to copy it to your answer. And that's really what screwed me up. I did not spend enough time planning, and if I did, I would have scored much better. I probably would have gotten a 4 instead of a 3, which I probably got 3. So, what I have for you today is a part 2, the part A of the first part 2 question on the test that I took for AP Computer Science A 2017. I don't know if this is really legal to show you this before the questions are released on College Board, but technically it's not the same question, and you're not going to find this anyway, so let's just get into this. This is the first part A of question 1 on the part 2 questions. So what this part A had you do is it takes in a positive, it makes you write a method. In this case, I call it toList. On the test, it'll be specific. It takes in a positive integer number and stores the digits of the number in an array list of integer objects. So array list of integer objects in the same order as the number. So, for example, if you have a Java program and you do my array list equals myObject.toList, so the method, and then you enter number 16,395. This is the number we'll be using for the example. The result would be it would return an array list containing an array of integer objects. So you would have all the digits in this number stored in an array of integer objects, and that array would be in the same order it was passed as the number was passed. You would get 16395 if you were to print it out. Alright, so let's go to the method itself. Public array list, because it returns an array list of integer objects. toList, the name of the method, and then int n passes a number. So we're passing 16,395. This is the number that we're going to use for the whole program, in this whole demonstration. So my implementation here, I did string, digit length string equals, and then in this expression I put n plus quotation marks. Now, the reason why it's not just n here, like if I just had an n, I would get an error. It would say incompatible types because you can't set a string equal to an integer, which is n. So by adding in the quotation marks, it turns this whole expression right here, n plus quotation marks, into a string literal because these quotation marks signify a string. So essentially, you're setting a string to the value number that is passed because no other characters in that string. So then next line is int digit length equals digit length string dot length. So what this does is it gets the length of the string that we just made, because you can't just get the string of an integer. So I made a string object, and now we got the length of it using the dot length method of the string class. So this digit length variable and this expression right here, this method also you could say, allows us to get the number of digits in the number that we passed. And right here, it's basically doing the same thing. This is a different way to do it. It's basically doing the same thing in these two lines, but condensing it to one line. Because when you have this right here, it's basically identifying this as a string, and it does string.length, and it gets the length of this, which is 16,395. So it would return 5. basically this line is just these two lines are one line. I just did it this way because it's more readable for me, and that's how I operate as a programmer. Let's move to the for loop. For int I equals digit length minus 1, so in this case our length of our number and digit length string is 5. So for I equals 5 minus 1, so the for loop starts at 4. I is greater than or equal to 0. I minus minus. You'll see why I chose these values for the for loop later on. So double next, I did it mainly because of the array. When you don't want to have like an out of bounds, that's why it's like greater than or equal to 0, and we're setting array objects at depending on certain indexes. So it's just really because we're dealing with an array list here. And just for my certain implementation, that's how I did it. So we have double next equals n, 16,395, the number we passed. Next equals n modulus, which is the operator that gives a remainder of this expression, math.pow 10 to the I plus 1. So I, if you recall, is 4, because it's digit length minus 1. Our length from the string that we created, is 5, which is, the amount of digits in the number we passed. So then we get math.pow 10 to the 4 plus 1, because I is 4. So this expression equals to 100,000. I'll do it in the calculator just to show you. 10, that's 5, yeah, 100,000. Yeah, 10 to the 5th, remember I is 4, I plus 1, 10 to the 5th, 100,000. So next is going to be equal to n, which is, remember, 16,395, modulus 100,000. This expression is 100,000. So when you have a modulus operation where this first number is smaller than this second number, it simply returns the smaller number. However, if this were greater than this, it would just return the remainder. But in this case, this first number is smaller and this is greater. So whenever you have that, it returns a smaller number. And I can show you an example of that in a compiler. Let's compile and execute this code. Basically, I just copied all the iterations of the math.pow method I'm using in my method. So don't worry about the lower ones. We're starting with 100,000. So we're going to print out next. And double next equals the expression we just had, 10 to the 5th, math.pow 16,395 modulus 100,000. Well, sorry, 100,000. And that yields 16,095, as you see here, is printed. Go back to our program. So while next is greater than 10, which it is, remember, it's 16,095.0 because you did a double. Next equals next divided by 10. So what this is going to do is going to truncate each basically digit off of next. So if you do that in a calculator, you'll see, hold on, let's do 16,095 divided by 10. All right, we get 1,639.5. But the 0.5 doesn't matter because we're going to cast it to an integer eventually. Let's go back here. All right, and we have a while loop, so it's still going to be greater than 10. Remember, 1,639.5 is greater than 10. So we do the operation again. Next equals next divided by 10. Let's divide by 10 again. 163.95 greater than 10. 16.395 also greater than 10. Now we get 1.6395. That is not greater than 10, and we found our digit. Notice how there is only one place here to the left of the decimal sign. That is our first digit. And now the while loop finishes. You get integer j equals new integer. Here we're casting the value of next to an int. So the 1.6395 in Java, when you cast something as an int, it doesn't round. So you get a 1. Digit list.add j, which is 1. Alright, that was our first iteration. Let's go to the next one. For int I equals digit length, it started with 4. Greater than or equal to 0, I minus minus. So we have I equals 3 now. Yes, I equals 3. Double next equals n, 16,395 modulus math.pow 10 to the third power. No, fourth power, I'm sorry. I is 3, I plus 1 is 4. 10 to the fourth power. And if we go here, we see that the expression will equal to, I'm sorry, I don't know why it does that. This right here, that's 6,395.0. So we go back to our program, and also just to remember, in that case, 16,395 is greater than this expression. So instead of, since this number isn't smaller, it actually gets the remainder. So the remainder of 16,395 divided by 10,000 would be 6,395. So next is going to be 6,395, which is indicated right here. So since that's greater than 10, we're going to divide by 10, right? So 6,395 divided by 10. 639.5. We're in the while loop still. Next, greater than 10, that's true. Divide by 10. 63.95. That's more than 10. Alright, let's divide by 10 again. We get 6.395. That's not less than 10. It's time to make this into an integer object and cast it as an int, get that decimal off. It doesn't round up, it rounds, it just cuts the decimal off in Java when you cast something as an int. So we would get 6. And look at that. We're adding the integer object of 6 to the array. So now we have 1 and 6. See, now it's making sense why I chose these values. I wanted to start with a specific index on the size greater than or equal to 0, because this essentially is the last digit. I'm sorry, this last digit. We're starting with the largest base digit and going down to get that 5. So we've added 1 and 6. Now we're going to go through the loop again. So we have, it started with 4, I is greater than 0, greater than or equal to 0, I minus minus. So now we're at I equals 2. Double next equals n modulus 16,395 modulus math.pow 10 to the 2 plus 1. So 10 to the third power. Go over here. This iteration. To the third power, so we're up to this part right here. It returns 395. Gets a remainder of 16,395 divided by, gets a remainder of essentially 1,000. And then when you do that, you get 395. Alright, is 395 greater than 10? Yep. Let's get rid of that decimal. Greater than 9.5. Greater than 10? Yep. 5 by 10. We have 3.95. So, what do? Put in the 3. Integer j equals new int next. Int takes off the decimal of 3, so 3.95 is not 3. And now we're adding 3 to, or equaling the integer object to 3, and we're adding that integer object. Now we have the first 3 digits of our number, 163. Let's go through the loop again. Now I is start at 4, greater than or equals 0. At this point, I is 1. Double next equals n modulus math.pow 10 to the 1 plus 1, so 10 to the second power. 10 to the second power, or we're getting the modulus of 100 here, from 16,395 modulus 100. And what's that? That is, sorry, I don't know why it does that, I'm sorry. It's 95 though, it's 95. So, you go here, you have your double next equals 95. That's what this expression equals to. Well, 95 greater than 10. Just remember it's a double, so it's 95.0. So 95 divided by 10 is 9.5. Remember in the while loop it's greater than 10, so it goes to the while loop. And then next is now 9.5. 9.5 is not greater than 10. So now we have integer j equals new integer, casting the next 9.5 as an int, so we have 9. The integer object j is set to 9, then we add that to the list. Boom, 1, 6, 3, 9. We have one more digit left. Now I equals 0. Now you can see exactly how I thought this through. This with the indices where the for loop starts and everything. I'm sure you could have done it a certain way, but this is just how I thought of it. And I equals 4. I equals greater than equals 0, so we're equal to 0. So it's still going to run I minus minus. Double next equals n 16,395, that number, modulus math.pow 10 to the I, which is 0 plus 1, so 10 to the first power. 10 to the first power obviously is 1. While next, or 10, right? No, hold on, I'm sorry. While the modulus, sorry, I forgot the modulus. While 16,395 modulus 10, well, that's greater than equal to 10, greater than 10. So let's check that. The modulus is not greater than 10, it's 5. So next equals to 5.0, double. We do not go through this while loop. Integer j equals new integer, int next equals 5. We truncate the 0.0 off. We're adding a integer object j, a value 5 to the integer array right here. Alright, when the for loop goes again, I minus minus, it's -1. The condition is not satisfied, so we drop out of the for loop. Then we return digit list, which we have been adding across throughout the whole for loop. Alright, we reached the end, so let's just test this. Once again, we're going to be using the number that we'll be using the whole example. 16,395. We do this in main method, int number equals 16,395. Array list mylist equals new array list. You set mylist to a blank array list of any type, meaning declare type. Number to list, which is the class name, right here. Digitizer equals new number to list. And notice how there's no constructor in the method. I think that's okay. It's there's either a default constructor that it's just invisible, or you can just create objects without a constructor. I'm not really sure on the specifics of that. Sorry. Mylist equals digitizer. So digitizer is the object that we created, so we have access to the methods of the number to list class that we were working with. Equals new. Mylist equals digitizer.toList. So the method, and then we're passing a number, 16,395. Number we were working with the whole video, and then we print that list. So without further ado, let's run this and put this to sleep. It's time for me to go to bed, 12:47. 16395. And that is one possible solution for part A of the first part 2 question on the AP Computer Science exam for 2017. Thank you.